So PLC stands for, okay, so programmable logic controller. Okay, so most of the industries nowadays no are into programmable logic controller, whether it is or whether no, so the team is composed of mechanical, electronics, or electrical, no, so so long as it is an industrial plant, then the system, no, so or the overall system is being monitored, and it is being commanded by this what we so called programmable logic controller. Okay, so we will be discussing, no, so in our topic for tonight, the functions and its application, and then the general some sort of general consideration in selecting a programmable logic controller, and then in the simulation we will be using a specific model, no, so of a PLC brand. Okay, so why we choose that particular model? So the answer is it is because that is the only PLC that the software can provide, no, so for free. So meaning to say the software that I'll be giving to you in a while, no, so after the meeting is free, no, so you can use that later on. Okay, so for practicing, for implementing activities, and even if you go outside, I mean after your, for example, graduation, you can still use the software, no, for simulation purposes, no. So we have a lot of uh, trainees in our training center. We have a lot of trainees, no, who are adapting, no, so into PLCs, no. So they are actually electricians, technicians, no, so who are working with uh, a number of machines, no. So they opt to go into PLC, no, after knowing the advantages, no, so of having a programmable logic controller. Okay, so again, no, so we will be discussing the functions and the applications of a programmable logic controller to industries, no. So when you say industries, we do not focus to, or we do not focus only to the electrical part, nor the mechanical part, no, or the electronic part, but to the process, no. So we will be talking about processes, and then that particular process, no, so is being commanded and being monitored by a programmable logic controller, okay, or PLC. So what are these PLCs, no? So and how do they work? Okay, so a PLC, no, so or a programmable logic controller is basically we can translate that into a tiny, no, so a very small computer, so which has its own operating system. So the one that you can see in the picture, I mean in the slide, no, so is uh, a model coming from Siemens, not brand. So it's actually Siemens logo PLC. Okay, so that is the one that we will be using, no, so in our activities, no, so the Siemens logo. Okay, so PLC in general, no, so not just for Siemens, no, so but in general, a programmable logic controller is basically a computer, no. So this computer or this very small or tiny computer can do, no, so a very sophisticated task. So but you have to take note that even though a PLC, no, so is a tiny computer, or it can be uh, synonymous, no, to a computer, the PLC can only perform a specific function designed or depending on what is programmed in the PLC. So beyond what is programmed in the PLC cannot do uh, those other things, no? So for example, if a particular PLC, no, or programmable logic controller is designed, okay, so you program a PLC for this particular process, and then you incorporate another process, no, in that existing PLC, then the PLC can only accommodate what is, no, or it can only command what is being programmed to it, or depending on what program is being loaded, no, so to the central processing unit of the PLC. So if the additional existing process, no, that you incorporate, or the newly additional process that is being incorporated, no, so in the PLC is not part of the program, then the PLC cannot do something to that particular process or newly added particular process. So it can take note, no, so although it is synonymous to a computer, it can only, okay, function based on what is being written to it, no, or what is being commanded, or what is being loaded, no, so to the central processing unit of the PLC. Okay, other than that particular command, then the PLC cannot do nothing, or cannot do something, no, so other than the given command. Okay, so the command that I mentioned is the program, no, so being made by you, or the engineers, no, so, or the programmer. So beyond that, then the PLC cannot do, no, so beyond those command or program. Okay, it has its own, no, so it has its own operating system, meaning to say that the command, no, so of the given PLC can only be written, no, so it can only be written using a specific programming software. So for example, in this particular PLC Siemens logo, so we have the logos of comfort, no, so that is being used to write, or that is being used to command, no, so the given PLC. So other models, no, other PLC brands also has its own programming language, so I mean programming software, no, so, and of course with the corresponding programming language. Okay, so PLCs are often defined, no, so as miniature industrial computers. So as I mentioned a while ago, a PLC contains, no, so it contains hardware and a software used to perform control functions. So for the hardware, no, so for the hardware, so mo ni ang parts, no, sa PLC, no, the hardware part. Okay, so we have the input module, no, so the first part is the input module. Okay, so this is where we connect, no, so the switches, no, so I'll be expounding this later on. So the input module, no, so is the part of the PLC wherein we connect, no, so the switches. So what are these switches, no? For example, the push buttons, as you can see, the limit switch, no? So you have the limit switch, kani. So this is sa maning lingin, pressure switch, no? So all switches are connected, no, so in the input module, no, so of the PLC. And then another part, no, so of a PLC is the power supply, no, so of course this gives power, so you can see, no, to the input module, to the output module, no, so of the PLC also. Okay, so in the output module of the PLC, you can see, no, so in the output of the PLC, it is where the loads, no, so are being connected. So what are these loads, no? So kaning symbol, so this is given by the solenoid valve, no? So this one, so this is given by a relay, no? So whose designation is given by letter M, no? So this one, okay, so this is signal light, no? And then this one, the last one, so this is a symbol, no, for the buzzer. Okay, so every loads, no, so will be connected in the output module, no. So when you say load, by the way, no, so when you say load, so these are the elements in the pneumatic system, for example, no, since we are talking about pneumatic system. Okay, we will be limiting our what you call this one, elements, no, so to the pneumatic system for us to understand, because a PLC, no, can also be used, no, so in other types of system. It could be hydraulics, motor controls, and others, no. So but since the course METE 381 is into pneumatic system, so we will be focusing the entirety, no, so of the examples or the elements that we'll be using to the pneumatic elements only. Okay, for you to be able to grasp, no, so what are these elements. Okay, so again, no, so in the input module, so we have there the switches, no, so as far as you can recall, so the switches that you have been using, no, so in your activities in the past, no, are example, you have the push buttons. Another type of switches there is the limit switch, no, so that is another type of switch. And another type of switch that you used, no, in your previous activity is the reed switch. Okay, so what are, again, no, so what are these switches? So the switches that we mentioned are the elements, no, in the pneumatic system, okay, that enables opening or closing a contact, no. Okay, so basically switch, no, so is defined as an element which make or break contact, or basically open or close, no. So for the load, the output module, so these are the elements, no, so that will basically be energized or de-energized, no. So when you say energized, so that will be the elements that will be turned on, and when you say de-energized, so these are also the elements that will be turned off. So example, a solenoid valve, this one, so when you supply the solenoid valve, the coil of the solenoid valve will be energized, no. So when you remove the source, no, so the 24 volt DC source, the coil, no, of the solenoid valve will also be de-energized, no. So example, the relay, no, this one, the relay, coil of the relay, no. So when you remove the source, so the relay will be turned off, and when you put the source, no, across the coil of the relay, so the relay will be energized. Okay, so another one, of course, the lamp, this one, lamp, no. So it's very clear, no, so that when you put the lamp, no, across the source, so the lamp will turn on, no, so or will be energized, no. So when you remove the source, so of course the lamp will turn off. Buzzer, although we haven't used the buzzer, but then buzzers are used for indication, but then in terms of uh, audio, no, auditory part. Lamp is for visual, and then buzzer is for auditory, no. So in case there is let's say fault, no, or something is wrong, no, in the control circuit, so you can use the buzzer, okay, aside from the lamp, to indicate that there is something wrong, no, so in the circuit. So the buzzer will create some noise, no, so which will alert perhaps the operator that something is wrong, no, so in the circuit. Okay, so that is the output module. And then we have the central processing unit, no, or the CPU of the PLC. So it is where, okay, so it is where we write, no, or we store the program. Okay, so PLC alone, you have to take note, no, so the PLC alone cannot work by itself, no. An engineer or a programmer must write, no, so must create a program. Okay, so this program will be the given command, no, of the PLC, and then once it is being loaded, no, in this case you have here a computer, for example laptop, no, so you write a program using the software, and then the program is being transferred to the CPU, no, so of the PLC by means of. So how do we transfer the program, no? So we have the what we so called PLC programming cable, no? So depending on the type of PLC, so there are a lot of programming cables, no, that can be used to transfer the program from the PC, no, or computer to the CPU. Okay, so we will be having some examples of that, no, so later on. Okay, so going back in this case, no, so way back around earlier the 1960s, no, industries are being commanded by relays. No, as you can see, no, in the bigger picture, so you have there hundreds of relays, no, relays na sila, no. So now we call this technology before as relay logic, no. So which means that the sequence, no, or the command of the, for example, pneumatic system is being governed by relays. So which is actually the one that you were doing before, diba? If you can recall, the sequence of the pneumatic system, example, in your midterm, no, you were asked to create A plus, B plus, and so on. So you use relay, no? You use relay. So in order for the PLC, or in order for the pneumatic system to follow the given sequence, which is, for example, A plus, B plus, A minus, B minus, and so on, or depending on what type of operation you want. Diba? So you use the relay, no? So to enable the cylinders to run in this sequence. Okay? But the problem of the relay logic is that when one, no, when one or let's say a few number of relays will be damaged, then you will have the hard time to locate, no, which of the relays are being damaged. No? So example, you have here hundreds of relays, no, so you have to test. Uh, the most difficult part is that if you are new, no, to the environment, and then you will be asked to trace why did the system goes down. Okay, so you have to trace which part of this, or which of these relays, no, are malfunctioning. Okay, but in today's technology, no, so this number of relays, kani sila, no, so these hundreds or even thousands of relays is being replaced, no, so that is being replaced with a very small element, no, as you can see in the smaller picture. That very small element is the what we so called programmable logic controller. So in the programmable logic controller versus the relay logic, no, so you can see in the relay logic you have there hundreds, no, depending on the type of process you have there several relays. But in the PLC logic, no, when you use PLC, so all of those relays, no, so those relays are being replaced by one programmable logic controller unit. Okay, so meaning to say this bulky part of the relays, no, so is now being replaced with a very small, okay, small yet powerful element which is being called the programmable logic controller. Okay, so now this is how we illustrate, no, the difference between the relay logic and the PLC logic, no. So if you try to look at, for example, a very simple example is that you have here a relay, no. So relay. So we normally open and normally close contact, no, and then you have here the coil of the relay, no, this one, and then a switch, no, so a switch. So you want the lamp, or you want to, or in the relay logic concept, okay, so meaning to say we incorporate the relay. So we wire, no, so you use wire, no, so to connect the lamps. Okay, so like in this manner, the two lamps will be connected. Okay, so to these terminals now of the relay. So might as well with the switch, no, so that is connected to the terminals of the relay. So we call this one the wiring diagram, and then the equivalent ladder, no, or we call this in electrical engineering this schematic diagram. So actually you're familiar with the what we so called in mechanical engineering, the schematic diagram can be synonymous to the free body diagram, no. So in the schematic diagram, so the connection of these elements, no, so it's given by this ladder diagram. So you have there the switch, which is in series with the coil. Okay, the normally open contact of the relay is in series with lamp number 1, and then the other one, the normally closed contact of the relay is in series with lamp number 2. So what will happen is that before you switch, or before we switch the rotary switch, no, so the lamp number 2 is being energized, no, meaning to say it is on. But when you click the switch, no, when you push the switch, the relay, no, so the coil of the relay will be activated. Then this contact here becomes closed. Okay, so making lamp number 1 to be turned on, and then on the other hand, it will make lamp number 2 to be turned off, no, so because the normally closed contact of the relay will be open. Okay, so if you implement this one, no, so using of course the relay logic, you have to wire, no, so the equivalent wiring of this one is the one at the left side, no, so the wiring diagram. So you have the source, okay, so which connects the lamp and so on, no, so meaning to say you have to wire series, parallel, and so on. So you will be wiring this one, the ladder diagram, okay, connect wire to the relay and so on, no? But then if we implement this one, okay, in the, or using the PLC, okay, so this would be the appearance, no, so if we use, no, the PLC, so we use, for example, a PLC, no, coming from Siemens. So what we do is we connect, no, so all we need to do is we connect the switch, no, to the input, no, of the PLC, no, so this would be the input module of the PLC. Okay, and then on the output module of the PLC, okay, as you can see, no, so you have there the lamps, no, so, or the loads, no, so which are connected, no, to the output module of the PLC. Now the ladder circuit, this one, okay, so if you try to look at this one, diba? So this is the ladder circuit, okay, which is to be wired this way. So meaning to say, this schematic diagram, the actual wiring of this one is this one, no? So the wiring diagram. So you connect the switch, this one, to the coil and so on. But then in the PLC, as you can see, the wiring in the PLC is basically only the input and the output. Okay, so where is now the ladder diagram, no? Or where is the ladder circuit? Okay, the ladder circuit is still present now in the PLC. The main difference between the relay logic and using the PLC is that in relay logic, the ladder diagram will be implemented physically. So this diagram here will be implemented physically using, of course, the element switches, the coils, and so on, depending on what are the elements now in the given schematic diagram or ladder diagram. But in the PLC, the ladder diagram is implemented virtually. Now, so as you can see, although they have different symbols, but then this ladder diagram here is now, or actually is the same as with this one. Kani, no? Okay, so, but then this ladder here is implemented physically. When we use PLC, the ladder circuit is implemented virtually, meaning to say, you will not be wiring these elements, no, physically, but you will be doing it inside the computer. Okay, so this will serve as the command, no? So this will be the command once this program is transferred to the PLC, no? So actually, you create this one in your computer and then you transfer it to the PLC. And then once it is inside the PLC, your system or the PLC will run depending on this circuit, no? So this will be the what we so called brain of the programmable logic controller. Okay, so later on we'll have no, so an example as to how will we create this one. But then the logic between the relay and PLC is that in relay logic, no, or when you use relays, when you implement the system, no, using relays, you will have to wire, no, so meaning to say you will be wiring, no, so the components physically. But when you use PLC, there is still the ladder circuit, but it is done virtually. Now, so meaning to say we create this ladder circuit in our computer. Okay, so that's the difference between the PLC and then the relay logic. No, for do not be confused. Do not be confused, because if you try to look at the system, this one. So this is a very simple system, no? So and then since it is a very simple system, it can be done, no? So it is preferable to do it the use or the concept, no? So of the relay logic, meaning to say it is more economical to do it this way rather than do it using the PLC logic, because in the PLC logic you need to buy, of course, the PLC, no? But for complicated system, okay, so in for example industrialized setting, so you can save, and then at the same time the troubleshooting will be made easier, because imagine, no, imagine, let's say you have there hundreds of relays, 100 relays. Without the PLC, you have to connect those relays, no? Meaning to say you have to wire all of those relays physically. But then when you use the PLC, instead of wiring those relays physically, so what we need or what we do is we create, no, or we create the circuit virtually. So when you say virtually, it is done using the computer. Well, of course, you do not connect, for example, you cannot, this line here, so it's actually a wire, but then it is a virtual wire, not so meaning to say it is inside the computer. But then using the relay logic, this line here represents a physical wire, so which connects the switch to the relay, no? Okay, so that is the difference between the relay logic and using, of course, the PLC. So we will be summarizing, no, so the advantages and then the disadvantages, no, so having a PLC. Okay, so the first part, what makes PLC advantageous, no, so as compared to relay. So in a PLC, it is cost effective, no, so which means that if the system is very complex, no, so PLC will be at the advantage part, no. So again, why? Because a single PLC can replace hundreds of relays, no. So but then the disadvantage of having the PLC is that, of course, for a very simple system, no, kung simple system, so you better use the relay logic, no, rather than the PLC, because of course PLC is expensive as compared to a relay. So a PLC, a simple PLC may cost more than 20,000 pesos, but then a relay, let's say a single relay will only cost less than 1,000. Okay, but then if you have there 100 relays, and then assuming that each relay will cost less than 1,000, for example, then the overall cost of the system may be higher as compared to a single PLC, no. So uh, PLC, no, so is flexible, no, so and can be reapplied to control other systems quickly and easily. So the second statement means that the program you created, no, for a given PLC can be copied, no, so it can be copied, no, so using an SD card, for example, you can copy the program from one PLC and then transfer it to the other PLC, no. So that's why it's flexible, no, and can be reapplied to control other systems quickly and easily. So you don't have to rewrite the program again. So all you need to do is to copy the program from the existing PLC and then load it, no, or transfer it to the other PLC of the same system. Okay, so that is the this second statement commonly happens when, example, in an industrial plant, you are a new engineer, no, and then the original programmer of the system is already out of the company, and then you want to know what's the program, no, of the PLC. So you can ask, for example, the overall or general manager, no, so for the password of the PLC, wherein you can extract the program, no, from the PLC. You can extract it and then modify it if you want, and then transfer it to the other PLC, even if, no, without the presence of the original programmer. Okay, so PLCs also can handle computational abilities, no, so meaning to say it can compare values, no, it can compute, no, so even mathematical operations. But then again, of course, a PLC needs to be commanded, meaning to say a PLC alone cannot do computational abilities, no. The programmer or the engineer must be able to write the program, okay, so, or write the formulas, no, in the program for the PLC to calculate it, no, so using the written formula in the program. Other than the formula in the program, the PLC cannot do its own calculation, no. So another one, troubleshooting aids, no, so make programming easier and reduce downtime. So of course, as I mentioned to you a while ago, the wiring, no, of the PLC, when you use the PLC, that's done virtually, but when you use the relay logic, it's done physically. So meaning to say, kung or shall we say there is, let's say, trouble, using the relay logic would be uh, a very tedious task, no? So you have to know which part of the, let's say, overall, or which part, no, of the relay system is being damaged, no, or being corrupted, or being or malfunctioning, no. But in the case of the PLC, since it is done virtually, no, so that means your wiring cannot encounter loose contact, it cannot encounter broken wire, okay, because it is done virtually. Okay, so and then using also PLC, from time to time you can monitor, no, you can monitor which part of the circuit is not performing correctly. So meaning to say, using the PLC, you can monitor from time to time which component, no, or which components are let's say being damaged or not performing correctly. Okay, so and then of course PLCs are designed to operate, no, for years before failure. In fact, we have some scenarios wherein uh, our trainees, no, in our training center, actually they both they brought, no, so the PLCs installed in their machines 30 years ago to the training center. They donate it, okay, so because they are already upgrading, no, so the or the previously installed PLCs. So imagine, no, so the PLCs are, or the PLC, no, is there commanding the equipment for 30 years, no, and then uh, it is only being replaced because the industrial plant owner wants to upgrade, no, so the old components into new one. So but then even without the upgrading, those PLCs can still command, no, so the given machine, no, so even though it is already phased out. Okay, so these are the types of PLCs, no, so that's available in the market. Okay, so we have there the first one, the compact type PLC, no, and then the second one, so we have there the modular type PLC. So let's try to take a look at what is a compact type PLC, no. So a compact type PLC, no, so these are PLCs with uh, built-in modules, no. So when you say built-in modules, di ba, if you can remember, the parts of the PLCs are the input module, the output module, the central processing unit, and the power supply, right? If you can remember. So in the compact PLC, all of those components are being placed, no, in one compact body. For example, in this one, in this first PLC, no, so the input module is here, and then the output module is also found, no, below. The power supply is also integrated, and then the CPU is also integrated, okay, in the system. So as you can see, for compact PLCs, all of the modules are being put, no, so in one place. Okay, so that's what we call compact. Okay, so compact PLCs are, of course, they are used for small system. So wherein you need to save a space, no, for the PLC components. But then we have the other type, the modular one, no. So if you can remember, we have the modular PLCs. This one. Okay, so the second type is the modular PLC. Okay, so in the modular PLCs, so each of those components of the PLCs mentioned, the CPU, the input module, the output module, and then the power supply. So these components are made separate, no, so with each other. For example, in this case, no, so the red one, I think this is Mitsubishi, no, so this is the power supply, the red colored, no, part, and then the second part is the CPU, and then the other components are the input and the output modules, no, so they can be detached, no, so meaning to say you can remove the power supply from the unit, no, you can remove the CPU from the unit, you can remove the input from the unit, you can remove the output, no, from the unit. So unlike with the compact type, that all of the components, no, are being integrated into one place, no, or one body. So that's why we call that one as compact, no. So all of the components are being held, no, in one place. But for modular, it's not. So the supply is different, the input module is different, the output module is also different. Well, for modular, the advantage of having a modular PLC is that you can expand, which means when you say expand, you can what we call this one, you can add, no, you can add another component to the existing component. For example, you need to increase the number of inputs, no, so you add another input module, and then you want to increase the number of output, then you add another output modules and so on. Okay, but then of course that depends on the model, no, so you cannot just add multiple number of inputs and outputs, no, so to the PLC. So that depends also to the type of central processing unit the PLC has, no. So meaning to say, although it is modular, but then the uh, PLC also has its own limitations as to how many components can we plug in, no, so to the given CPU. Okay, so but then you can in the modular you can add, no, so another components and another components, but in the other type, the compact one, so you cannot do it, no. So the disadvantage of using modular PLCs is that if your system is small, the modular PLCs are very bulky, no, so meaning to say you cannot save a space, no, using modular PLCs. So only you can save a space when you use the compact type PLC. Okay, so the PLC can be further divided into two, no, so that depends on the output of the PLC, no, so it's either you can have the solid state or you can have the relay type output, no. Okay, so for the solid state output, you have there the triac type, and then you have there the transistor type also. Okay, so triac type, okay, just remember, perhaps you will encounter this later on. No, so triac type, these are intended for loads, no, so which are being supplied by AC source, no, and then transistor type. So these are the loads, no, or the loads, no, intended for transistor type are the DC DC loads, no, so those operates direct current. Okay, similarly in the modular type, so the same, no, so you have the solid state output or the relay output, no, and then the solid state output, okay, can be classified as triac or the transistor type. Okay, so okay. Okay, so let's try to take a look at what happens, no, so to the input, no, so of the PLC. Okay, so as mentioned a while ago, input, no, so in the input module of the PLC uh, is where we connect the switches, no. Okay, so an example in the illustration is the push button. Okay, so in the PLC input, okay, so the function of the PLC input is to identify, to take note, no? So the function of the PLC input is to identify if the connected element is open or closed. Again, uh, we'll have to understand this one, okay, so for us to easily grasp, no, so what will happen, no, in a PLC. Okay, so in the input module, no, so of the PLC, so the input module of the PLC will detect, no, so the function of the input module of the PLC is to detect whether the device connected into it is open or closed. That is the only function of the input module. Okay, so that is why we only connect to the input module the switches, no, because the function of the switch is to create or break contact. So the PLC input module will then identify if the switch is open or closed. So how do the PLC input module identifies, no, if it is open or closed, no? So let's try to take a look at this one. So the input or the push button or a switch, no? A switch is connected, one end of the switch is connected to the positive terminal, no, of the 24 volt DC source, no? As you can see. And then the other end of the switch is connected to the input module, no, of the PLC. So what will happen now is that when the push button is closed, no, this one, as you can see, so the voltage that can be measured from this point to the ground, okay, from this point, no, to the ground is 24 volts. Now, as you can see, no, so when the push button is closed, so the 24 volt voltage can be read, no, it can be read in the PLC input module. But when the push button is open, okay, as let's say it's open, then the voltage from this terminal to the ground is 0. Okay, so meaning to say, the PLC can identify if the switch is closed, if there is the voltage that can be measured, no, so in the input module terminals, and then the PLC can identify if the switch is open if there is 0 volts, no, so that can be measured between the input terminal and the ground, no. So in this case, for example, so how do the PLC works, no? If you can remember, if you have your basic computer subject, no, I think you have it. So computers can only identify signals 1 and 0, no? So it's either 1, 0, 1 or 0. It cannot identify 24 volts or 0 volt, no? So it's basically 1 and 0. So if the PLC input module can detect 24 volts, then the PLC input module will record that as 1. Okay? Memory 1 or bit 1. So if the voltage is 0, then the value, no, is 0. So meaning to say, the PLC, okay, will give 1 to the central processing unit, or the input module of the PLC will give 1 to the central processing unit if the push button is closed, and it will provide 0 signal to the central processing unit if the push button is open. Okay, so hopefully you got it, no? So it's not the 24 volts that is being fed to the central processing unit, no? So again, the central processing unit can only identify 0 and 1, no? So binary signal, no, 0 and 1. So 1 if there is a voltage, and then 0 if there is no voltage. So if there is a voltage, then that means the push button is closed, and then if there is zero voltage, then that means the push button is open. Okay, so now there are two types of what they call this one, input connection, no, PLC input connection. So we call this one the syncing input and the sourcing input. Okay, uh, you need to understand this one because in the future, you will be working with, no, so in some of the industries, no, in the Philippines, no, or perhaps outside the Philippines, no, if you want to venture outside, there may be cases, no, that you will be asked to, for example, recommend uh, a PLC input module, or shall we say a switch, no, to be connected to the PLC input module. And then there may be times that you got the wrong element, no? So you have to understand the concept of syncing and sourcing, no? So what is this? What is the syncing and sourcing part of the PLC? So we have the syncing input and the sourcing input, no? So what's the difference between the two? Try to observe what happens now between the two. In the syncing input, okay, the positive terminal now so of the source is connected to the switch itself, as you can see. And then in the sourcing input, as you can see, no, in the sourcing input, the positive terminal of the source is directly connected to the PLC unit, as you can see, no. So in the syncing input, the negative, no, so the negative terminal is being connected to the PLC. In the sourcing input, that is the positive terminal that is being connected to the PLC. Okay, so so that's the difference between syncing and sourcing, no. So basically, if you try to look at the running line, the light blue line, so we call the input, no, to be syncing, okay, if it absorbs, no, current from the source. And then we call the PLC to be sourcing if it gives, no. So try to take a look at this part here. The current flows to the switch going into the PLC. In the sourcing input, okay, so the current goes to the PLC and then it gives the current to the switch, right? Okay, so since we cannot see the direction of the current, we cannot see, no, so the direction of the current. Okay, so we just identify, no, so the type of the PLC by looking at the connection of the positive terminal. No, if the positive terminal is being connected to the PLC directly, then that is sourcing, like this one. But if the negative terminal, this one, no, ground, is connected to the PLC directly, then that is syncing. Okay, so what's the importance of syncing and sourcing input? So we have the what we so called, I think you have your basic electronic subject, no? So we have actually, guys, no? So we have actually electronic components which are polarity sensitive. Okay? So example, the reed switch, no? So the reed switch, if you use it in the actual, uh, there may be cases, no, that the reed switch is polarity sensitive. So a reed switch could be a PNP type or an NPN type sensor. So meaning to say, if the let's say the reed switch is a PNP type switch, no? So take note, if that is a PNP type switch, then it must be paired with a syncing type input. Okay? So take note, no? So if it is a PNP type, then it must be connected with a syncing type. Why? Because the configuration of the syncing type input is that the negative terminal of the source is connected to the PLC directly, as you can see, no? So which will work if the sensor is PNP type. And then if the sensor is NPN type, no? So try again, no? NPN type. So the configuration of the sensor is that it will only run, okay, take note, no? It will only run if, try to take a look at this one. It will only run if the configuration will be this one, no? So the terminal, this one, is connected to the ground or negative. The PLC must be supplied with the positive, no, input, no, or positive terminal. Okay, so what will happen if an NPN type device is connected to a syncing type PLC input? So the answer is that it will not run, no? So most of the what we call this one, malpractices, no? So PLCs in the industry is that the sensors, no? So the sensors are not correctly paired with, no? So the equivalent input module. So for PNP type, so actually guys, if you want, if you shall we say purchase, no, an electronic switch, no, so you have to specify whether it is PNP type or NPN type. Okay, so because it will really matter when you connect that to the input module of the PLC. So PNP type switch can be connected only to a syncing input module. NPN type switch can be connected only to sourcing type module. Okay, so you have to remember that one, no? So once you interchange it, then it will not function. Okay, so the output, no? So the output of the PLC, no? So as we mentioned a while ago, there are two types, no, of PLC output. So we have the solid state. Okay, so whether it's using triac or transistor type, no, and then the other one is the digital output or the relay output. So the difference is that for relay output, it's actually a switch, no, this one, as you can see. For the solid state, so it's actually a switch still, no, it's actually the same function as a switch, but then the concept of the solid state is that, for example, if you try to look at this one, if you focus your attention, no, so in this part here, the transistorized type, no, so when the current flows in this way, okay, so if the current flows in this way, so the solid state or the transistor will allow the current to flow, no? But then if the current flows the other way, for example, if you let the current flow here, going to here, then the transistor will not allow the current because it's actually reversed bias, no? So you recall, no, so your basic electronic subject, no, so on how the transistor works, no. Okay, so the Siemens logo or the PLC that we will be using, no, so in the software is using actually relay output, no, meaning to say we will focus our attention in the relay output type, no. So the function of the relay output type is to open and close, no? So once the contact opens, this one, if this opens, so it will not allow the flow of current. If this is closed, no, so it, of course, it allows the flow of current. So whether it is coming in this direction or the other way around, so long as the relay is closed, the relay output is closed, it will allow, no, the current. But for the solid state type, no, so it will only allow the flow of the current in a given particular direction, which means, for example, the current will flow. Let me write, no, so I can have, so for example, the current will flow here. So of course it allows, no, so because the direction of the current is from this point going to the other point, no. But then if we, let's say, let me erase this one. Okay, let me have a pen. But then if you have a current to flow in this way, so the output of the PLC will block, no, so the current, because it will not allow the current in the reverse direction. So it's basically a switch still, no. It's actually almost a switch because it allows and blocks the flow of current. But then the concept would be different, because in a relay type output, the current will not flow because it is open. So in the solid state, the current is not allowed or does not flow because it is going in the other direction, no. So that's the difference between the relay output and the solid state, no, output. So again, no, so we will be using the relay type, no, output. Okay, since that is the only output available, no, in the simulation software. Okay, so relay versus the transistorized type, no. So hopefully you will be able, no, to recall in your basic electronics subject how come the current will not be allowed to flow if it is going in the other direction, no. If you have the solid state device, no, such as the transistor and triac. Okay, so okay, next is the concept, no, of the PLC, no. So as you can see, I'm almost done, no, with the presentation. uh, we will proceed, no, so with the simulation of the activities. Okay, so this is how we visualize, no, or conceptualize a system using PLC, no. So we have here push buttons, no. So normally open push button and normally close push button connected to the input module, no. So this one, so this block here is the input module, and then the second part here, this one is the central processing unit of the PLC. So in the central processing unit of the PLC, so a program is being, okay, so as you can see, a program is being written, okay, in the central processing unit. And then in the output module of the PLC is connected, or a relay, no, a relay is connected. We call this one magnetic contactor. Perhaps you are not so aware of the magnetic contactor, but we can have a synonymous element with this one as with the coil, no, of the solenoid valve. And then this is the cylinder instead of a motor. So what will happen is that if you give an input, okay, let's say you press the push button, so the push button will become closed. The input module of the PLC will read, no, so the 24 volt or it will sense, no, that there is a 24 volt supply it will give one signal to the processing unit. Okay, so when it gives one, so the ladder program here from open, as you can see, no, start is open. When it is being given with one signal, so that means it is closed, no. So then the program, okay, so the program here, this part here will become closed, and then it will activate, no, it will activate this part here, the output, no, address of the output. So once this activates, no, so the output or the address of the output is being activated, so it will also provide one signal. So once the output gives one, so meaning to say it allows the connected element to be energized, no. For example, if this is a solenoid valve, okay, so once the output gives one, then as you can see, current or the output, no, so allows the current to flow to the in this case the magnetic contactor. Let's just make it a solenoid valve. So once the solenoid valve is energized, of course the cylinder will extend, right? Okay, so that's the process, no. So what we do in our activities is that we first we connect the elements, no, the input and the output, and then we write the program, no, so to the PLC. So first is we connect the input elements to the PLC. Second is we connect the output elements to the PLC, and then after which we incorporate, no, so we what we so call this one, we write the program to the PLC, and then after which we execute, no, so the program, and uh, given that the program is correct, so the connected elements, no, in the output side will run uh, accordingly as given, no. So okay, now we will be using the what we so called, okay, let me, okay, stop the same, okay, let's share another one. Okay, so okay, let me share content. Okay, so this would be the PLC, no, that we will be using, no, so the Siemens logo. Okay, so this would be the physical, or this is actually the physical appearance, no, of the PLC. It's actually a compact type PLC, no, so wherein you have there the central processing unit, no, inside, and then the input modules, no, on the topmost portion, and then the relay output module. Okay, the relay output module. Okay, so at the bottom part of the PLC. So these are the available variants, no, of the PLC. So you have there the logo 1224. So actually the numbers indicates the supply voltage, no. The 12/24, that means it can be supplied with 12 volts or 24 volts DC. So kung 24 alone, that's 24 volts AC. 230, that means 230. No? The source is, or the PLC can be supplied directly with the voltage coming from the outlet, no? Which is 230 volts. Okay. So R, by the way, if there is R, that means that's relay output, and then if there is no R, then that means it's solid state. For Siemens logo, we only have the transistorized type output, no? We do not have the triac type, but only the transistorized type. So again, no, transistorized type is intended for DC voltages, no. But for triac type, so that's for AC, no, or alternating type. Okay, so R, that means relay, no. So again, as I mentioned to you a while ago, so for relay output, it does not matter, no. It does not matter whether it is AC or DC. So because the function of the relay is just to open and close, no. But for the solid state outputs, so the type of supply to the load, DC or AC, will actually matter, no. As I explained to you a while ago, so in the transistorized type, when you suddenly connect, no, the source in the wrong polarity, it could be, or there is a tendency that the output, no, of the PLC will not work because the output part of the transistorized output PLC will not allow, no, so the flow of the current when it is or when the polarity is being reversed. Okay, so this is how we connect, no, so the PLC to the source. Okay, so for 24 volts, no, for DC supply, so we just connect the source, no, of the PLC to the positive and negative, no, terminal. For 230 volts, that's connected to line 1 and line 2, no, or basically L1 and N. Okay, so how do we connect inputs, no? So if you try to look at, inputs are connected, no, so in the PLC logo in a manner such that the positive terminal, no, of the source is connected to one end of the switch, and then the other end is connected to the input address. So meaning to say, Siemens logo is what? Is it a sourcing type or a sinking type? So the answer is, sa man si Siemens logo, so is it sourcing or sinking? So the answer is, it is sinking type. Okay, why sinking? Because if you try to take a look at, the positive terminal is not connected directly to the PLC, no, so the negative terminal is being connected. Okay, positive is connected to one end of the switch, and then the switch is connected to the input address, so making it a sinking type PLC. Now, so now for 3-wire, okay, so for 3-wire switch, so there are actually switches, no, so composed of 3-wire. So all you need to do is to connect the 2-wire to the positive, and then the other wire to the negative, and then the other wire, no, must be connected to the input address. Okay, so the PLC default, no, or the Siemens logo default inputs are numbered I1 up to I2, I3, and so on. No, so remember, it's I1, I2, I3 up to depending on how many modules, no, so we add to the PLC. So we can go up to around I20, no, I1, I2, I3, and up to I20. Okay, so for the 230 volt variant, all you need to do is to connect, no, one of the switch terminal to line 1, and then of course the other terminal to input address, no, I1, I2 up to it could be I20, no. So that's how we connect, no, that's how we connect the input, no, of the PLC. For the output of the PLC, okay, as you can see, no, the output of the PLC, so since this is a relay output, So load, no, one of the terminal of the load is connected to in series, no, with the switch. Okay, actually it's connected in this way. Okay, so a one end of the load terminal is connected to one of the relay output, no, and then the other terminal of the relay output to the source, no, and then the other terminal of the load to the other line of the source, no. So basically we connect the load, no, of the relay output, no, if the PLC is relay output, so we just connect the load in series with the relay output of the PLC. No, so actually it's a switch, no, like this one. So for those who are using cell phones, I'm not sure if you will be able to uh, see, no, so the annotations made. Okay, so for example, if this is the switch, no, relay output of the PLC, which is actually labeled Q. So it starts with Q1 up to Q2, Q3, and so on, no. So the output of the PLC is, or the output, no, or the load, no, of the PLC is connected in series. For example, if you have there a lamp, this one, so the lamp is connected in series like this, no. So it's connected in series. One end of the PLC output is connected to, for example, positive, and then the other end of the lamp, for example, is connected to negative. Okay, so once the output of the PLC is activated, it will close. No, so this will close, and then uh, since it is now closed, so the current from the positive will flow to the lamp, for example, going back to the negative, making the lamp activated. No, so basically it will turn on. So if the output of the PLC is deactivated, so it will open, and then the lamp will of course will be turned off. Okay, so let me erase first, no, so the annotations. Okay, so for the transistorized output, no, of the PLC, okay, so we connect it directly this way, no. So we just connect it across, no, so the PLC output. But then, as I mentioned, the transistorized output, no, of the PLC is only for DC. So if your load is taking AC, then you cannot use the transistorized output of the logo, no, or the transistorized type logo PLC. So because the output of the transistorized PLC, no, or the transistorized output of the logo is DC, which means it can serve only up to 24 volts DC. So good thing for pneumatics, because, or pneumatic system, because most of the components are supplied with 24 volts DC. But other than pneumatics, no, so if you want another load to be connected to the PLC, and then particularly if you are recommending the transistorized type, then you have to be very careful, because the transistorized output, no, or the transistorized type PLC can only give 24 volts DC, whereas the relay type output, no, so you can supply whether AC or DC, no. Okay, so that's how we connect, no, so the logo output, no, of the, or the output, no, of a logo PLC. So from now on, we will be using the relay type, because what's available in the simulator is the relay type output, no, of the PLC. So we do not have the transistorized one in the simulator. Okay, so These are the logo programming language that we will be using, no, or can be applied. So we can use either function block or ladder diagram, but personally, I prefer the ladder diagram because of its simplicity. So you will still be using, no, the ladder circuit that you created, no, so from the past activities. And then all you need to do is to translate that into a ladder program. Okay, so we'll have an example to that. Okay, so and then that would be the end, no, of the discussion, and then we'll have the sample simulation activities, no, activity. So okay, so a software will be actually uploaded, no, so in a while after the meeting, no, so I'll upload the software that you will be using, no, for PLC, no. So for the meantime, let me just um, open, no, so the software for a while, no. So let me open. Okay, so for a while now. So let me just open. Okay. Okay, so I'll be sharing now, so the software. Okay, so let's have it. Okay. mm, okay. I think there is. Okay. Okay, so you have there the software, no? So name Kadisymio, this one. So all you need to do is to open the software like this one. Okay, double click, no? And then okay, so why is it that I cannot share? No? So the okay. Okay, so this is actually the software, no, so that we will be using. It's actually Kadisymio. So it's actually computer aided. I forgot D and E. Now simulation. Okay, so the first time you open this one, this will ask for a password, no? So the password of the software is 4962. Okay. So I'll be giving it now so later on again. So for now, you focus your attention on how we do, no? So the activity, or how we perform, no, the activities. Okay. So okay. Now uh, these are the toolbars, no? So that we will be using. The elements of the software can be found, okay, in this row. All you need to do is to click, no? And then another elements, no, a group of elements will pop out depending on what elements you click, no? So you have there the push buttons, the sensors, the coils, and so on, no? So okay. So these are the elements, no, that can be used, no? So you follow the cursor, no, of the mouse. Anyway, I guess it's being recorded. Okay. So again, no, so you open this one, and then the password is 4962. Okay. So you can zoom in, no, so, and zoom out, no, so of the working area. So this is actually the working area. So by default, the size of this is A4, no? So you can change the size, no, or you just zoom in, no, zoom out, depending on your preference, no? You can actually change the size of the working area, no? So perhaps it would be best if we demonstrate, no, how we can change the size of the working area. So go to file, and then click file, no, and then setting. Okay, and then you can choose the size, no, so you can customize your own size, no. So in my case, I'll be using A3, no, which is double of that, the A4, no. So, or you can customize depending on your preferred size, no. So again, the default is A4, no. So A4 is somehow almost similar to a short band paper, no. So that's A3, no. I'll be choosing A3, and then click OK. Okay. So you notice that the size, no, uh, is already bigger as compared to the previous size, no, of the or the working area, no. So okay, first is we have to what we call this one, we have to uh, have some activities, no, so for us to implement, no, using a PLC. Okay, so we can have so we can have let me open, no, an activity. Okay, so let me have the first activities, no, that we have, first 4 activities, no. So let me open activity number 1. Okay, so okay. So for activity number 1, so you have the sorting device, no. So actually you were able to do this Okay, so we will be implementing this one using the PLC, no? So activity number 1, okay? So if you forgot, no, so the function, no, so of activity number 1 is that when we press, no, a push button, the cylinder will extend, no, single acting cylinder will extend, and then once we release the push button, the single acting cylinder will retract, right? Okay, so we will be implementing this one using PLC. Okay, so going back to the simulation software, okay, so let's try to enumerate what are the needed. Okay, so you can add, by the way, you can add text here. Okay, so just click this portion here. Okay, so click this one, and then you will, or you can have, no, you can type uh, text, no, in the working area. For example, this would be activity number 1. Shall we say sorting device, no? You can press OK, no? And then so you can click, no, anywhere in the working area. So you can click anywhere in the working area where you want the text to be located, no? So for example, you want it in the bottom part. So there is actually a title block, no? So titulo, no? So you can click it there, click, no? And then automatically the text you type a while ago will be placed in here. You can adjust the position of the text. Okay, so you can double click and then click font, no, if you want to change the size of the font, no, shall we say 14, then you want that to have a color red, or let's say blue, for example, click OK, and then OK. Okay, and then your, okay, so you will have, no, so you will have the uh, title of the activity, no, which is sorting device, no. So you can add another text, no. You can click this one, the existing text, and then copy, no. So you just use Control C, Control V. So and then you drag it, no. You can drag it to the, again, no, portion in the working area you want the text to be located. You can double click and then let's say type, no, designed by. So you can type your name, no, so if you want. So in this case I'll be typing my name, no. So designed by, so the date. Okay, so that's automatically updated, no. So okay, so this one, no. So in our activity, for activity number 1, we will be using PLC to implement the sorting device, no? So meaning to say, since we will be using a single acting cylinder, okay, the single acting cylinder, we need to have the power circuit first, no? So to locate the single acting cylinder, okay, in the second row, no, so you can click this one. Okay, so you have a portion here, no, so pneumatic actuators, this one, just click. Okay, and then you will be given with options, no. Okay, then you can use single acting actuator or you can use double acting actuator, no. So since we will be using the single acting cylinder first, no, so we can click this one. So all you need to do is to click, no? Do not hold the left button in your mouse, no? So just run your mouse, no, move your mouse without clicking the left uh, button, no? So just move the cursor of your mouse and then click in the working area where you want the element to be located. So click. After clicking, guys, if you notice, the cylinder is still, no? Or the single acting cylinder is still there. If you continue clicking and clicking and clicking, so you will be putting a lot of cylinders, no, in the working area. So just make sure you click, no, so to that particular portion wherein you want the system to be located. So to remove, no, so to remove this element, no, in the cursor of your mouse, you can press the ESC button in your keyboard. Okay, the one situated in the upper left, no, ESC. So just click that, and then if you notice, the element uh, is already removed, no, from the cursor of your mouse. So by the way, you can adjust the position. So just click the object, no, click and then move it, no. So depending on where do you want that particular element to be located. Now for the other elements, no, so like this one, so since they are already redundant, you can click them and then delete. You can do the right, okay, click that one and then, or, okay. So click and then use the delete button, no, in your keyboard. Click and click, no, like this one, okay. So let's, okay, for activity number one, it's actually made of single acting cylinder, no. So double click the pneumatic or the pneumatic power circuit. Now just double click, and then you can edit, no, you can edit the name of the cylinder. For example, that's cylinder, you can type it cylinder A. By the way, you can only use 5 characters, no, so you cannot type fully cylinder A. So in my case, I type CYL_A. And then you can uncheck, no, you can uncheck the sensor because activity number one does not need the sensors, no. So actually, captador magnetico, this is actually reed switch, and then final de carrera contraído is actually the let's try, no, let's try. If we check this one, okay, by the way, that's 3-2-way, no, 3-2-way monostable. So the name of the coil is A plus, no, remove the minus sign, no. So actually it's minus A plus, no, so just remove the A plus. Make sure not to add space after A plus, no, so that's actually another element being added. So remove the space after A plus such that the name of the solenoid coil is actually A plus. If you put a space, then the name of that solenoid is A plus space, no? So make sure you remove the space part. So just 3-2-way monostable, and then okay, click OK. As you can see, the sensor, okay, present in the cylinder are reed switches, no. But if you check this one, the second set, this one and this one, and then you uncheck these two, So what will happen is that the sensor will be now a limit switch. Okay. So the good thing about the simulator is that once you choose a system, you have already there the cylinder, the sensor, the flow control valve. At the same time, the what is so called this one, the uh, compressor, and of course the solenoid valve. No, unlike with the fluid sim that you have to add one by one. No, so we can so we can double click again and then remove the sensor by so unchecking, no, so because again activity number one does not need a sensor. Okay, so this is a single acting cylinder using 3 two-way valve. Okay, so if you try to read again, activity number one is using only single push button, no? So that means the push button that is in activity number one is connected to the input, no? Normally open push button. Okay. And then the output, no, in activity number one is actually the solenoid foil only. So we begin the construction of the control circuit. No? So this will be the power circuit, and then the control circuit will be implemented in the program, no? So using the PLC. No? But first, we need to connect the input and output now of the PLC. Okay. So first, we need the power supply. No? So power supply, just click this icon. No? So in the second row, so the power feedings, no? So we can have the positive and negative terminal, this one, no? Okay, so actually there is a separate positive and separate negative, or you can choose both, no? So the positive and negative, just click again, click. So once you click, do not hold the left button, no, of your mouse. So just let the mouse run, no? So and then click the click that particular or click after, no, so after clicking the icon, so release the what you call this one, release the left button, no, of your mouse, and then just move the cursor, no, move the, or you move your mouse, no, so and then select, no, so to where you want the particular element to be located by clicking it again. So you click it, and then again, if you notice, the element is still in the, or together, no, with the cursor of your mouse. You can press the ESC button, no, in your keyboard. Okay, click, and then this time you can click another element. Okay, another element you want, no? So I'll just zoom in. Okay, so this would be the power supply ito. So you can double click this one, and then you can type DC source, no? uh, let's say DC, no? So, or you can just leave it. Okay, so with the original what you call this one, original label, no? So in my case, I changed that to DC and then click OK. Okay, so and then we okay. Uh, okay, so the PLC, no? The PLC. So for the PLC, okay, where do we find the PLC? Okay, so in the input output, okay, icon, okay, this one IO. click that icon, and then you will be prompted with a lot of elements, no? So choose the third one, that's logical module, no? So this one, okay? Click the logical module, okay? Just click it and then remove or release, no? The cursor, release the uh, left button of your mouse, and then just move the cursor of your mouse, okay? So this would be the appearance of the, I'm zooming it in. Okay, so this would be the appearance of the PLC, no? Okay, so assuming you place it here, okay, and then after which press, no, the ESC button in your keyboard. Okay, so you can either choose, by the way, no, so the top view format of the PLC, no, if you try to look at, no, so the first two terminals of the PLC, P1 and P2, serves as the supply, no, of the PLC. P1 positive, P2 negative. Okay, and then you have there the 8 input terminals, no, the input modules of the PLC. This one, I1 up to I8. Okay, and then at the bottom part, so you have there the output, no, so module of the compact PLC relay type, no, so relay. Okay, so you can use the top view, what they call this one, top view uh, format of the PLC, or you can double click this one. Okay, double click the PLC, and then you can use the black and white version. Okay, if you want, no, so this would be the black and white version of the PLC. Okay, and so by the way, no, so again, this is positive and negative, no, so just make it positive and negative supply even if the label changes to L1 and N. Okay, or you can use the double click again, you can use the relief photo, no, so the 3D version of the PLC. Okay, this one. Okay, so this will be the 3D version of the PLC. And then you notice that in the 3D version of the PLC, there are actually wires, no, coming from the terminals, no. So that is why I like the 3D version, because in the 2D version photo, no, so you have to connect to the elements. No, example, you want to connect positive. So let's say you click these cables and connection. So this is where we uh, get, no, so the uh, connectors, or basically the wire, no. So you can choose the thickness of the wire, no, from width 1, width 2, width 3, width 4. Width, of course, width 4 to be the largest, no. So there is no restriction actually, no, as to what thickness do you want to use, no? And then the color bar, no? So both we have black, the blue, and then the green. We have also the red and black, no? So this one, positive and negative. Okay. So although you can use no any of this wire, no, so that depends on you, no, depending on what you intend to use, no. So you can use the phase wire, the black colored wire, or you can use the colored wire, this one. Okay, you can click this one and then choose the color of the wire you intend to use. So for example, green, you have the colors, no, at the right side. So you can choose green, yellow, or whatever color you intend, no. But then I suggest you use the common colors, no. So the red and the black, no, color wire. Red for positive, and then black for negative, no. So that would be okay, no. So for the positive wire, for example, you click this one, no, positive wire. When you use the 2D version of the PLC, okay, so I am zooming it out, no, for you to be able to see. So you click, example, you connect wire, no, all you need to do is to click the left button of your mouse and hold it, and then you move the cursor, no, up to, for example, P1. That's what you have already connected it to the uh, P1 terminal. So take note, do not cross the border, no, in the picture, no, of the PLC. Like this one, for example, you intend, let's say you want to use a thicker wire or a bigger wire. You choose width 4. Okay. So when you use the blue colored wire, so let's say you connect it this way, no, so it won't work, no. So if you use the 2D version, so make sure that the wire is limited only up to the periphery, no, of the drawing, just like this one. Okay, so you can move the cursor, by the way, like that. Okay, and if you, for example, let's say you initially draw the wire in this area, okay, or this position, and then you want it to connect in this point, no. So all you need to do is to, for example, click uh, the selected wire color, no, and then proceed with, okay, so proceed with wiring starting from the last part, no, of the cable, no. So for example, you end up here. So to connect wire, so all you need to do is to start here and then move to the left and then drop it downwards like that, no. So there may be times that you accidentally release, so for example, you draw a wire and then you release the button, no, of your mouse. So to continue, you can actually continue, no, so the connection, so by starting with, no, so to the last point you ended with the previous wire. For example, you ended here. All you need to do is to continue, either continue to the right, you can move upward, or you can continue, move to the left and then move downwards like that, no. So now for two wires, for example, you connect, you want to connect, no, another wire, no, from here, or you want to tap another wire, no. So you want to connect it here, so the software will automatically, for example, you connect a wire here like that. So if you try to look at, there is a presence of the dot, no. So which means that this wire and this wire are connected. And if you try to look at this one, okay, this wire going up, going to the left, and going downwards. So please take note that these 2 points here, even though they cross, they are not connected. So for example, you have a red colored wire, this one, and a black colored wire, so which crosses the red colored wire like that. So do not think of the two as connected, no? So they are actually not connected unless otherwise you put a connection point, no? So this one, okay, so this icon, just click with that icon and then move that icon to the point wherein you want those crossing wires to be connected. Once you click it there, okay, and then press ESC button, no, in your mouse. So this is the time wherein the black colored wire and then the red colored wire are connected. But if they do not have the connection point, then that means they are not connected. Okay, so just like this one, this line here and then this line here, so they are not connected. Okay, so if you want, for example, to connect, no, if you intend, so if you intend to connect, let's say to I2, so let's say you have a wire and then move to the left and then just, okay, connect within, no, so the boundary. Do not cross the boundary, no, of the picture of the PLC. Okay, so it will not be connected. But if you transform this one, okay, so by the way, if you intend to use or select another object, so you can click this icon here, redraw, okay, so that you can click another object. No? So if you transform this one into 3D version, okay, let's try to transform this one into 3D version. Just double click, click relief photo. No? So please press OK. As you can see, so the elements that you initially, no, or the wire that you initially connect to the 2D version will automatically be connected, no? So to the outer wire, okay, so connected or which is provided by the 3D version. Okay, so I do not know which one will you use, no? So the 3D version or the 2D version, it's up to you, no? So it's up to you. You can use the 3D or the black and white version or the 2D version, no, of the PLC. But in my sample simulation, I'll be using the 3D version. Okay. So now we go to implement, no, activity number 1. Okay. So I'll be zooming it in. Okay, so I'll be deleting these conductors or wire, no? Okay, so you can select the cables individually and delete, no? Sometimes, by the way, sometimes like this one, no? So I selected an item, but then as you can see, no, I already selected the item, but then what happens is that the program or the software does not allow me to delete. Then you click ESC button in your keyboard to refresh the software, no, and then you can click again and then delete, no. So if you cannot delete the item or the component, okay, so or if you cannot let's say for example in this case, no, I'm choosing the or I want to delete this group of wire. Okay, so at once, so I can choose all of them. Okay, so by highlighting all of them and then click delete, no, or you can choose to click individually and then delete like this one. Okay, so or you can choose to highlight all the elements and then delete. uh, if there are cases, no, that you cannot delete again, you press the ESC button, no, in your keyboard to refresh the software. Okay, so since this is a free software, so we expect that there are some bugs, no? So in the software that the developer was not able to perfectly what we call this one implement, no? So perhaps in the upcoming years, no? So if the developer of the software will be uh, doing some bug correction, then the better, no? So but for now, you can, no? There may be times that the software will hang, no? So all you need to do is either uh, you have to save, no, from time to time your work, okay? So or you better close the software and then start again, no? So okay, for activity number one, we have the single push button, one push button, no? So to be connected in the input of the what we call this one, the PLC, no? So first is we connect, no? So the supply of the PLC, okay? So we connect the positive, no? I'll be using the third, okay, with 3, no, for the width, no, of the cable or the wire. So I'm actually using the red colored wire for the positive, no. So take note, no, so that you will be doing wiring here, no. So meaning to say you will be connecting wire. So do not put, okay, so do not place your PLC like this one, like you just put the positive source, no, so this one directly to the PLC like this one. So it will not work in that way. So all you need to do is to have a space, no, between two elements and then connect the two elements using the cables, no. So just like this one, okay, so we choose cables and connection, and then you choose the color of wire or the thickness. It's up to you, no? So on what thickness do you intend to use? So for positive, okay, so just click again, click, no? Release the uh, left button, no? So of your mouse, and then just move the cursor of your mouse, and then start clicking, no? To the element you want the wire to be connected. For example, in the positive, so I start with, no, make sure you start with the terminal, no, of the positive source. Do not connect, no, from the circle, no. So connect from the this terminal, no. So drop it to the positive terminal of the PLC. And then for the negative terminal, negative supply, no, this one. Although you can use red wire, but then it would be better to use the other color, no? So the black colored wire. Drop it and then make sure you end up with, no? So the correct termination, okay? And then for the PLC, okay, for the PLC, or for the input, no? So we have one normally open push button. So for the push button, so go to drive button. Okay, so where is the push buttons located? So in this icon, you have there the drive button. Okay, click the drive button and then you will be given with a lot of options. No? So you have there normally open push button, normally close, and then a lot of options. So we click, push button, just click. Again, do not hold the left button of your mouse. Just move the cursor of your mouse, no? So as you can see, no? And then place it in the working area where you intend that particular element to be located. So for example, in this case, I'll be putting the push button in here, okay, and then press ESC button. So double click, and then you can press or you can rename this one with start button. So again, the maximum number of characters that you can use in the labeling is 5. Okay. So how do we connect input again? Also in Siemens logo. So one end of the switch is connected to the positive. No? So where's the positive terminal? So click cables and connections, and then positive, no? The red colored wire, and then start from the positive, no? You can choose it here, here, or you can start it here. Okay, so positive. As you can see, okay, so there is this connection point, which means this wire and this wire are connected. However, the red horizontal wire and then the black vertical wire, so they are not connected. Okay, so we connect, no? So we connect the push button to the positive terminal like that, and then the other end to the assigned input, no? So we can make use of the red colored wire again, no? The same wire. So drop one step downward and then move to the left and then downwards. Okay, so which means that the push button is connected to input address I1. Okay, now let us check if the push button is connected properly, no? So you can click the simulation button, this one, which means you are turning on the supply, no? So just click this simulation button, okay? And then as you can see, your PLC is energized, which means you correctly, okay, you correctly connect the PLC to the power source, okay? Now, okay, if we press start push button, for example, if we press start push button, okay, as you can see, uh, the positive signal, okay, goes straight, no, so to the input I1 address, no, I1, and as you can see in the screen of the PLC, so the push button is being detected by or into the I1 address, no. So that's actually I1, I2, I3, and up to I8, no, because there are 8 inputs, no, of the PLC. So which means that the push button is connected properly. So if you press the push button and then nothing happens when the I1 address, then that means that there is something wrong with the connection, no, of the push button. Okay, so to the PLC and from the positive terminal. Okay, so now how about the what we call this one? How about the output of the PLC? No, so the output of the PLC will be connected, or the load, no, so will be connected to the output of the PLC output module, no. So the output module of the PLC is connected or situated at the bottom part now of the PLC, no. So, assuming that you convert this one to 2D, no, so double click. Okay, so just stop the simulation first, by the way. Stop, double click, and then if you intend to use photo, so as you can see, the positioning of the wire must be at the periphery, no? Periphery of the PLC. Do not cross with the boundary, no? So it won't work actually, no? So now for the uh, output, Okay, so take note, no? So take note, it's actually a switch, no? This one is, it's actually relay output, no? So we have actually four labeled Q1 to Q4, right? Q1 to Q4. Okay, so how do we connect the output or load, no? So, but the question first is, uh, what are the loads, no, of the system? So we have the what we so called um, coil, no, of the solenoid valve, okay, which is A plus. Okay, so this is the load, no, of the PLC, no, so the coil. So we connect the coil to the output module of the PLC, no. So what we want to do is to connect, no. Okay, so we convert again this one to 3D. Okay, so you notice that this wire is connected to 1 and then this wire is connected to 2, the same way as with the other outputs, no? So relay output. So we need to have another supply, no? Or we can, you can have positive terminal from this source, negative terminal from this source above, or you can have a separate source, no, which I think would be better. So go to power feedings, okay, and then click power, no, power plus minus, this one, click, and then you can put it here. Okay, so by the way, at the upper part you can double click and then you can have DC underscore input, no, IN. So which means that is the supply for the input. And then at the bottom part, you can have DC and then underscore O, which means this is supply for the output, no? Okay, or just basically DC out. Perhaps you can write it that way. And then at the upper portion, basically you can have DC input, no, DC space input or in, no, and then at the bottom part that's DC out. Okay, so how do we connect in outputs, by the way, no? So first we have to identify what are the load, no? So as I mentioned, that's the what we call this one, that's the uh, okay, that's the solenoid coil, no, or the coil of the solenoid valve. Okay, so where can we find, no, the coil of the solenoid valve? Okay, so go to, kindly follow the cursor of the mouse, no, go to um, coils and signals, no, so you have here coils and signals, click that icon, and then you find the coil, this one, solenoid coil. Okay, so click this one and then move the cursor of your mouse. Now again, do not hold the left button of your mouse, just move your mouse. Okay, so let's say we put it here. So I suggest you to have a space, no, so in between the lines coming from the PLC and the element, no, so that you click, press ESC, double click this one. Okay, and then label it A plus, no, so make sure not to avoid spaces, and if you are using capital letters, no, so in the labeling above, then you have to use capital letters also. Okay, so in here, okay, so that means this coil is actually this one. Okay, so how do we connect? No? How do we connect the coil of the PLC? So, uh, or how do we connect the coil to the PLC? No, the coil of the solenoid valve to the PLC. No, so we go to cables and connection again. No, click this cables and connection. So you will be prompted with the wire, no, so to be used. No, so this time I'll be using the phase wire. This one, the black colored wire. Or you can use this wire, no, for all the connections, no, so anyway it does not matter. Okay, so as to which color you intend to use, no, so click this one and then connect A1 to terminal 2, no, which is given by this one. Okay, and then the positive terminal of the DC source, no, of for the output, so you can choose the red colored wire if you want. So this would be the source DC. Okay, uh, and then move it to the right and then connect it to terminal 1. Okay, so actually your Q1 is actually in series with A plus, no? A2 now will be connected to, I'll be making use of the negative wire. Okay, so drop one step, okay, or move one step downwards and then move one step to the left. Okay, and then connect it to the negative. Okay, that's it, no? So your output, no, or your solenoid valve is now connected to the output of the PLC. Okay, so let's try to check, no, if we're doing it correctly, no? So we turn on the PLC by clicking the simulation button. Okay, as you can see, the red colored wire, no, so indicates that this is positive wire. The black colored wire indicates that this is negative wire. Okay, so now if you have already connected the input and output, no, of the PLC, okay, assuming that you have already connected it properly. So if you turn on the, or if you press the push button, as you can see, the cylinder does not move. Okay, why? Because again, the PLC will only allow, no, so or will only control the elements connected to it, no, so depending on the program, okay, or the command that the programmer is loading to the PLC, no, or writing into the PLC. As of the moment, the PLC does not have the program or command loaded to its central processing unit or CPU. That is why, regardless how many times we click the push button, the system will not work. Okay, as you can see now, so you press the push button, the coil is not activated, the cylinder is not activated. So the PLC needs the program, or needs a program to be written into it, no, for the PLC to function. Okay, so how do we do it? No, so we create a program. So how do we write the program? Go to, okay, go to the ladder, this icon here, ladder. Okay, ladder, and then uh, you will be prompted with different symbols, no? So this is the part wherein we create the ladder circuit but virtually. So meaning to say, we will not be doing these connections physically but within the computer. So first is we have to establish the virtual supply of the program. Click this positive part. Okay, so let's say positive, and then press ESC. No, you can adjust it. Okay, and then the negative, this one. Okay, so negative part. Okay, so press ESC after, and then you can have positive wire to be connected and negative wire to be connected. No? So you can make it longer or shorter depending on your own preference. No? Okay, so if you try to look at in the circuit, no? So the input is connected to I1. Okay, let me convert it into 2D. So the input, the push button is connected to I1, and then if you try to look at your coil is connected to Q1, no? So that's in series with Q1. Okay, so you can see. So the logic here is that when we implement the program of the PLC will not understand the start label of the push button. Rather, as I've mentioned, it will detect, okay, the presence of the voltage and then convert it into 0 or 1. Okay, so we will be doing the program like this one, no? So for the push button, okay, for the push button, so the push button will be uh, represented by a normally open contact, okay, NO. So this is a virtual contact, okay, which represents the push button, but we do not label this one with start. However, we label this one with the address of the push button. So the input address of the push button is I1. Okay, so just type I1. Okay, and then if we try to, for example, simulate. Okay, so if we click the start push button, physically the start push button closes, right? Also in the program, as you can see from the open contact a while ago, it now changes to close. Okay, so the color blue indicates that the contact is closed. Okay, now we release the push button, the contact changes to open. Assuming that you suddenly encode the wrong address, let's say I2, for example. Okay, so you run you run the simulation, click the push button. Now, as you can see, nothing happens to I2 because the push button's address is in I1. Okay, so you have to carefully uh, identify, no, so the correct address, no, of the input and the output. Okay, now instead of or in using PLC, instead of having a circuit, no, so which activates A plus, as you can see, your A plus solenoid coil is connected to Q1. PLC does not understand what is A plus, no, so but rather the PLC can understand which output address does you connect the A plus coil. No, for example, okay, in the ladder, so we have here the assign icon, this one. Okay, so in the assign icon, we connect the assigned icon, okay, in series with, so by the way, uh, we label this one Q1. Okay, why Q1? Because the solenoid coil is connected to Q1. So it's actually the same as with having a push button in series with the solenoid coil. But since we are implementing this one using PLC, the labeling of the ladder program or ladder circuit will be based on the address of the input or output elements, no? So for example, A plus is connected to Q1, therefore in the assign icon, uh, you use Q1, no, instead of A plus, no? So and then this one, this will be connected to I1, okay? And then we connect the two in series, no? So I1 is connected to positive, and then it's connected in series with Q1, and then Q1 is connected to negative, no? Or to put it, okay, uniformly with the other color, so the negative wire will be black, okay? You can use black, or basically if you want red, then you can also use red. It doesn't matter. Okay, so now if we try to simulate, for example, let's say, no, you focus your attention to the circuit, no. Okay, so this time, if we press the push button, no, okay, so focus your attention first with the, okay, I want you to focus your attention in the program. Okay, so now upon simulating, if we press the start push button, as you can see, okay, so if we press the start push button, as you can see in the program, the address Q1 is activated, right? It's actually indicated in the screen, no? So that the Q1 is activated. Why? Because basically, if you try to look at, no, so if you turn, or if you make I1 closed, so current will flow into the Q1, and then Q1 will activate, right? So what will happen if Q1 is activated? If you try to look at the output side of the PLC, no? So push button is activated, no? So if we press Q1, I'm sorry, if we press the start push button, so as you can see, this relay output, no? The relay output here will close, thereby energizing A plus, no? So let's zoom it out or zoom it in, no? For us to see the, so as you can see, if we press the push button, so you will have A plus to be activated, no? So which is indicated by the red color. So actually the purpose of Q1 here, Q1, no? So is actually to make this contact, no? Q1 contact here closed, no? So once this is closed, then of course A plus will be activated, okay? And of course, if that happens, no? So if you try to look at the cylinder, okay, so we'll move the cylinder here, okay? So if we try to look at, no, so the cylinder, if we press start, the cylinder extends, right? Why? Because upon pressing this one, so the output of the PLC activates A plus, no? So once A plus is activated, so the cylinder will, of course, extend. And once we deactivate or release this one, so as you can see, no? So the cylinder will also retract, okay? So that is the concept, no, so of having a PLC. So next one is, what if we want, no, we want the cylinder to uh, be steady, no? So which means that uh, upon pressing this push button here, even if we release, no, the push button, the cylinder will what we call this one, it will remain, no, in the extended position, no? So what do we do is we add, di ba, in our, okay, in our previous activities, no? So we add, or our previous examples, we add the sealing contact or latching contact, no? But in the relay logic, no? So when we use relay, we actually wire the normally open part of the relay, right? No, so if you can remember, when we use the sealing contact, no, so we have to incorporate a relay, no, so a physical relay, K1 or R1, no, R1, okay, because it is only the relay that can provide normally open contact, okay, or normally closed contact. However, in the PLC, it's not needed, no, because Q1 is functioning as a virtual relay, right? No, so this is actually a virtual relay. Q1 is actually a virtual relay, which means that it is found inside the PLC, which means that we can add a virtual contact without having a relay, diba? So in this case, let's say we add normally open contact here, okay, and then we label this one Q1, okay, which means this is a normally open contact of the relay Q1, okay. So but then you have to take note, Hana, this is not a physical relay, no, so it's actually a virtual relay. So we connect the virtual relay in parallel, I mean virtual contact na in parallel with. So you have to move one step to the right, no, and then connect it upward like that so that it will automatically connect like this one. Focus your attention in the program, okay? So do not look at the pneumatic system, okay? So let me remove this one first, no? Okay, focus your attention in the program, okay? So if we press the start push button and then release, so what will happen is that I1 closes momentarily, activating Q1, right? But since we release the start push button, the contact I1, no? So the contact I1 is open, right? Okay, so but Q1 is actually is still in activated mode because as you can see, the sealing contact, no, of Q1 is closed this time. Okay, so that enables the A plus coil to be activated always, which enables further that the okay, let me stop the simulation first and then okay, let's simulate again, no? So if we press start, okay, as you can see, no, the blue colored, okay, so once the contact is in blue color, that means it is closed, no? So when it is in white color, so that means it is open. So as you can see, the coil is being what do you call this one, energized because of the presence of the sealing contact, no? So virtual sealing contact. Then A plus is maintained, no, in energized mode. Thereby, your cylinder is remained in extended position. Okay. How do we what they call this one? How do we enable, no, so the cylinder to retract? Okay. So let me finish, no, so up to 9 so that we can have additional activities, no. So uh, if you remember the concept of the single acting cylinder, no. So for the single acting cylinder, you need to turn off A plus, right? Okay. So once you turn off A plus, the cylinder will of course retract, no. How can we turn off A plus? So we try to look at the program, we can only turn off A plus if the Q1 address is being turned off, right? So if Q1 address is turned off, then this contact here will open again, and then enabling A plus to be de-energized, right? So we need something, no, that will break the circuit, no? So, and then that is given by, so let me go back again to 3D. So we need what? A normally closed push button. So in a normally closed push button, this one, so go to drive button again, no? So normally closed push button, press ESC. Okay, so press ESC, okay, button in your keyboard. So we can make this one stop, or basically we can label this one retract, and then this one we label this one extend, EXT. So how do we connect input, no? So again, as I mentioned to you a while ago, so one end is connected to the positive, no? So positive wire, one end to the positive, that one, and then the other end to the assigned input, shall we say I2. Although you can choose your own, like let's say I3, I4, I5, I8. Well, it depends, no? So long as you remember the address of that particular switch. Okay, so how do we incorporate? Okay, so the next question is, how do we incorporate this push button, no, to the what we call the program? Okay, so before doing it, okay, so we need to understand, no, so how we represent a normally closed contact physically into the program, no? So hopefully you focus, no, so your attention in this part. Okay, so for you to be able to grasp, no, so why the normally closed contact will be presented in this way. So we go to ladder. Okay, so this icon, click ladder, and then we represent, or we click normally open, at the same time normally close contact, this one. Okay, so we label this one I2, and we label this one I2. Okay, so meaning to say, physically the switch is normally closed, right? But in the program, in the creation of the program, the programmer can, no? So meaning to say, the programmer can use the address, in this case I2, right? I2 is being connected, or the normally closed push button is connected to I2, right? So the address I2, no, or the input address I2 can be represented with normally open or normally closed contact. So the question now is, which one, okay, which one should we use? The normally open or the normally closed contact? Okay, let's try to take a look at the condition, no? So let me zoom it in. Okay, this one. And then we turn on the supply. Okay, now what happens is that, try to take a look at this one first, no? So focus your attention in this part here, no? So I2 here is open, and then I2 here is closed, right? And then this is a normally closed contact. Okay, so upon turning on the simulation, Okay, which means we energize the Siemens logo. Okay, what happens is that even if we do not press, no, we do not press the push button, the normally open contact initially of the I2 address is closed, and now the normally closed a while ago contact is open. Remember a while ago I said if the contact is color blue during the simulation, that is closed, and then if the contact is in white color, then that is open. So even if you tell me that sir, I2 is that part there is closed because the symbol is closed, no, that would not be the case, no. So in the PLC or in this software, you can identify, no, that that contact is closed during the simulation if it is color blue, and then it is open if it is white, no. So meaning to say this contact is open and then this contact is closed. Now if we press the push button, the normally closed push button, okay, so basically in this case if you try to look at, no, so the I2 address, no, I2 actually receives one signal, one. Why? Because even before we click the push button, the positive signal, no, of the source DC in is already fed to I2, no. So that's why it's, if you try to look at the screen of the PLC, it's already being in color black, right? So meaning to say it receives one. So the moment you click the push button, so you notice that the screen, no, so the I2 address becomes white. That means the signal now is 0 because as you can see the push button is already open, right? So every time the push button is closed like that, okay, so the address I2 receives 1. When the push button is open, I2 receives 0. Okay, so meaning to say the input, no, so the input of the PLC works depending on the signal being received by the input module, no. If the input module receives 1, then it changes the contact directly, no, the virtual contact. Okay, initially, di ba, this is open, but since I2 receives 1 from open during the simulation, it becomes closed, no? Then the normally closed contact initially, this one, di ba, this is closed. But during the simulation, since I2 receives 1, it changes the state of this closed, it becomes open. Okay? So try to take a look. If I press this one to, or try to take a look at, let's say for I1, no? Let's say we create I1. Okay, press ESC and then close. Okay. So if we label this one with I1 and then this one also with I1. So see, I presented I1, okay, which is open. So the address of I1 is being represented with open or closed, right? So what we need to do is that, okay, upon simulation, as you can see, the open, diba? This is open, this is closed, no? During the simulation, it remains open and it remains closed. Why? Because I1 receives 0, no? So it receives 0 because physically it is open. The moment we click I1, okay, this one, EXT, the moment we click this one, I1 receives 1, right? Okay, so it receives 1, so you can see. So the virtual contact, the normally open virtual contact becomes closed, and then the closed contact, no? So the closed or the normally closed virtual contact becomes open. Why this becomes open? Because again, every time the input receives 1, then the contact changes state, no? But then once it gets back to 0, assuming we release this one, okay, then the virtual contact goes back to its original state, no? So thereby we can say that in creating a program using normally closed contact, no? So for example, in this case, normally closed push button, okay, so you will be representing the normally closed push button with open contact in the program. Why? Because try to take a look at this one. During the simulation, this is closed. What happens to normally open I2 that is closed? So if we click this one, if we press this push button, physically the push button will be open. Try to take a look at this one. If we click this one, so the push button becomes open, so that's open. Then it follows that the I2 contact here becomes open also. But if you choose close, upon clicking this one, the contact physically is open, but then the virtual contact gets closed, no? So meaning to say, when we want to incorporate normally closed contact into the program, we will be presenting it with open, or we will be representing it with open virtual contact or open virtual contact address, no? So let me, for example, this one, no? We insert, no? So we insert the normally closed contact. Supposedly it's the push button, but then since the PLC can only understand the address, no? So not the push button itself, okay? So but the status of the address, no? So if we try to simulate, try to take a look at this one, open. Your I2 here is closed, which conforms to the status of the normally closed push button. Okay, so clicking this one, we click this one, the cylinder extends because of the latching contact, no? So it maintains the operation of A+. Okay, so Q1 on the other hand is being activated virtually, so which means that this Q1 here is closed, no? So clicking the normally closed push button, this one, if we click this one, so I2 receives 0 and then this becomes open. Okay, try to take a look at that one. Okay, so extend, retract. Okay, so extend, retract. Okay, so that's the beauty, no, so of the system with the aid of PLC. Okay, so hopefully, no, so you take the recording of this one, no, so I will be or we will have, no, more examples, no, complicated examples by next meeting, no. So guys, if I cannot enter the class, no, by next meeting, by let's say 7 p.m., that means I am not around in the city, no, by that time. Rest assured, by Friday, I will take time, no, to upload a recorded video, no, for the more examples. I mean, for more examples with regards to PLC. So the most important part is that you were able to grasp, no, so the concept, no, the basic concept of the PLC. Okay, so but I am not yet sure no if I can meet you by uh, Thursday no. So basta by 7 p.m. if I cannot turn on the theme. Okay, so then that means I am out of the city no. So I will be uploading no, so a recorded video by Friday no, as soon as possible. Okay, so guys, should you have questions no? So with regards to this one, so kindly message me no, sa Teams na to.
Sir, excuse me,
Okay?
sir.
Yes, yes, oh.
Sir, sa activity 5 to 8, sir, individual to, sir, or group, sir?
Oh, let's make it individual kay individual no kay uh, dili ta mo ma-check tagsa-tagsa na matawag na just like last time. So just make it individually, but I mean you can submit. You need to submit it individually, but you can work uh, by group gyapon.
Ang pag-submit ato, sir, is i-record, sir, ang
Pag-submit
simulation, sir.
lang individual lang, no? So
I-record lang ang
well,
simulation, sir, or ang file mismo may
sa no, one example activity 5 to 8 uh, every one of you will have to submit activity 5 to 8 uh, regardless if you work it by group or individually no so the purpose of having groupings no so is for you to work with no so to have brainstorming no so but that doesn't mean guys na if you are four in a group, then you will have to work only for activity number 5. For example, you need to work, no? You need to work all the activities, no? So, but there will be the case, no, na you might be asking for some help from the group, no? So, but you have to submit individually, no? So, for all the activities na to. So kung naay groupings na to and then dili mo let's say within the group no dili mo participate then of course well it's up to the group no do not give your work no with that member kay nahago.
ang i-submit, sir, sir, ang file, sir, or i-record na mo ang simulation screen record. Yeah.
Ay ang file mismo ang isubmit na to.
Sige, sir. Thank you, sir.
ah so guys no so kung natay questions then feel free to chat no sa Teams na to. Okay? So, sige no, if you have wala mo questions, then we'll call it a night no. Let's continue by next meeting. Okay, so pag-amping mo permente sa inyo.
Yes, sir. Thank you, sir.
Thank you, sir.